Okay, we've talked about linear functions, piecewise functions, and now we're looking at absolute value functions. So this is kind of the third type of function that we're looking at. And one strategy that I want you to really remember is, because we're going to look at a lot of different functions, and I don't expect you to memorize exactly what they all look like. But what I do want you to remember is to get an idea of what something looks like, how do you go about getting a graph? What can you do to get some points so you can draw a graph? Yes. Okay, you could find the x and y intercepts. Sometimes that's a good idea. You could set y equal to 0 and find x, or vice versa to find the other intercept. And then also, like you said, Alex, just plug in some numbers, just make a table. That's what I want you to remember. So if you have this function here, and like say we'll have over the course of the whole Algebra 2, we'll do a bunch of different functions, and it can be hard to remember what they look like. Just make a little table. Usually what I like to do is I like to do at least one negative, maybe throw in 0, and then a positive. That way you can get an idea of what it looks like on each side. So let's just put in, I'm going to put a couple extra ones. If you plug in -2 for x, what's the output for that? 2. -1, 1, 0, 1, 2. If you notice, as we know with absolute value, it always gives you an output of positive. Because what was the definition again of absolute value? Yes, the distance from the origin. Very good. So when you plot this, -2, 2, -1, 1, 0, 0, you notice you get a perfect V. In other words, the negative inputs come out positive, and the positive inputs come out positive. So you end up with this perfect V. What this models, can anybody think of something that models that? Anything in real life that would mean like slowing down and then speeding up again? Okay, that's not a bad idea. Anybody think of anything in sports? Or any activities that would give you a model like this? What's that? Okay, that's not a bad idea. If I had to demonstrate, if I had a ball and I threw it against the wall, whenever one of the properties of physics is that it says the angle of incidence equals the angle of reflection. Just like on a pool table. No, just next time you shoot a pool ball, and that's how you can decide where it's going to go. If it hits the side at 50 degrees, it's going to reflect off the side at 50 degrees. Say if you were to spike a volleyball, if you spike it down at 70 degrees, it's going to come up at 70 degrees. When it hits something, it's going to reflect back at the same angle. Okay. So those are some things that an absolute value function models. Okay. Now we're going to change some things. Here's our basic. All the different things we can change, the different variables that we can put in there. Okay. So if I give you, let's just say, and actually I think I have that on the next page. Yes, I'll just skip to that. I'm going to just give you the quick way to do it here. What you'll notice, if we were to just make some tables and plot some points, what you notice is that the point where it hits we'll call it the vertex, you can move around the vertex, move your V wherever you want. What you just do is you do the opposite of this number inside the absolute value, and you keep this number the same. So what that tells you, what you can read from that, The opposite of negative 6, that's positive 6. Keep 7 the same. That's going to be our vertex. Okay? So 6, 7, 1, 2, 3, 4, 5, 6, 1, 2, and then up 7. Here's our vertex. In other words, that's going to be the part where it hits the wall. That's the point of the V. Okay? This is your slope of the V. And if it's positive, it opens up. If it's negative, it opens down. So positive, it opens up. And negative, it opens down. So this is a positive 1/2. So we just go up 1 over 2, up 1 over 2, up 1 over 2. Same way, up 1 over 2. Here's our absolute value graph. You'll also notice if it's a number less than 1, a fraction like 1/2, 1/4, 1/3, it takes the V and it opens it up more. So this means that if it's a number, if this is less than 1, if it's less than 1, it means it's wider than the parent one or the basic one, just absolute value of x, makes it wider. In other words, when you put any number in there, like say 8, absolute value of 8 is 8, take a half of that, it now becomes 4, so it widens it up. Okay, those are the quick things. Yes? Yes. Yep, good question. Let's look at another one. So our vertex is going to be, this is just like Anna was asking about, our vertex is going to be the opposite of this one. So negative 3, you keep that one the same, negative 3, negative 4, so that's our vertex. Negative 3, negative 4, okay? Your slope now is negative 6. Since it's negative, what does that tell us? Opens down. And then our slope is negative 6. So it's down 6 over 1. So down 1, 2, 3, 4, 5, 6 over 1. You notice it's really steep. So now it's like if I threw the ball almost straight at the wall, and it came straight, almost straight back at me. It's a really narrow V. So, and then the other one will be over here. It just has, when I put, let's just say something like this. When I put a, just hold on guys. When I put, say like a negative 2 in there, negative 2 plus 2, that's 0. How could I say that?
So you always put in 1 in parentheses?
Yeah. I know I'm having a mind block right now to explain how that works, but yeah, just remember to always do the opposite. Yes, in the absolute value. But we just want to know where the vertex is. But you've got this subtract 4 at the end. So when you plug in negative 3 plus 3 is 0. So you'd have the absolute value of 0. You're plugging this in for x. So you're not taking the absolute value of negative 3. You're taking the absolute value of negative 3 plus 3, which is 0. And then you get negative 4. Yes. Okay. Now, you guys, what's that? That's by this number out front. If it's less than 1, it's wider. If it's greater than 1, it's more narrower. If it's 1, it just stays the same. Yes. So that's what you need to know to graph the absolute value. So you guys get both sides of that sheet done. Okay? And